Now we discuss the Newton's Laplace equation. In this, before we going to take out the speed of a sound by the Newton. What did the Newton said about the speed of a sound? Here we see the one of the formula, that is of what? C is equal to root of P by rho, which means of what? The speed of sound is directly proportional to the root of what? Pressure acting on a sound, and the inversely proportional to of what? Square of the density of any medium. In this, what happens actually he said about of what, and he take out the assumption of what? The pressure and the volume will be changes are isothermal, which means of what? The temperature will be constant and there will be no exchange of an internal energy in the system. This is what here to be considered. And what is the Laplace correction will be take out. Here the Laplace will be taken, or the correction what he had to be changed by the Newton's assumption. The pressure and the volume changes are adiabatic. In the Newton's assumption, what he taken, he took off the pressure and volume changes are isothermal, but in the correction of Laplace, what he said, the pressure and volume changes are adiabatic. Now we see what are the differences between the isothermal and adiabatic processes. Let's see, here there are some of the differences between the isothermal and the adiabatic process. In the system, what happens, the temperature will be remains constant in the isothermal process, and here there is the temperature can be changes. Here there is exchange of any temperature will taken place in the adiabatic processes, and here we have to see the heat transfer can be observed by the system, but in this there is no heat exchange will be taken place, because in this here there is an internal energy can be acting. In the work done due to the change in the net heat content of the system, the work done due to a change in the net heat content, because overall heat will be changes the work done. The work done is due to of what? The whole heat content of any changes, net content of any changes will be done. That will be the reason of any work done. Here in this, the work done is due to the change in its internal energy. Here the work done will be done by of what? Internal exchange of any changing of any energy. Here we say that because of any temperature constant, here the PV and P1 V1 is equal to P2 V2, and this means of what? Pressure and volume. Here the P1 V1 is equal to P2 V2, and here P1 V1 gamma is equal to P2 V2 gamma. Here we said that gamma will be the greater than of 1. That in numerical we said of what? Gamma will be the greater than 1. These are all the causes that there is the correction of an speed of a sound in the Newton's formulas correction by an Laplace. Here we see the graph. We have to be done the graph pressure versus volume. Here the pressure when the system, what happens, P1 V1 will be changes to the P2 V2, and here also the adiabatic will be these are the curves which we have to see for the isothermal, and this is for the adiabatic processes. Before, by the Newton's formula, what is that? Elastic bulk modulus is equal to the pressure, that B will be equals to of what? Pressure. But in the Laplace correction, what happens, the adiabatic bulk modulus will be, that is the K, that will be equal to of what? Gamma into pressure. This is what the correction made by a Laplace in the speed of an sound. At last we see the Newton's Laplace equation, that is C is equal to root of K by rho. What is that K? That K is the adiabatic bulk modulus, which is equal to of what? Gamma into pressure. This is all about what? The Laplace correction or Newton's Laplace correction of the speed of a sound.